Hey guys, how's it going? Super excited to start Unit 2. Unit 2 is all about quadratic functions. And so it's going to be looking at all those parabolas and different ways to solve for them and graph them and all sorts of fun stuff. So what we're going to do is we're going to start with 2-1 today. So make sure you have your notes out, and we're just going to go ahead and get started because that seems like the best thing to do. 3 objectives for today's notes. The first one is we're going to review how to analyze the graphs of quadratic functions. Okay, so where's the vertex? Where's the, what's the axis of symmetry? Where's the x-intercepts? Where's the y-intercepts? Things like that. Then we're going to write quadratic functions in standard form. And we're going to use the results to sketch graphs. Okay, so most of the time what we're going to be doing is we're going to be reviewing how to complete the square there, okay? And then the last thing we're going to look at is how do I find the minimum and the maximum values of quadratic functions in real life applications. So real world problems, how do I find the minimum and the maximum there? So just to review real quick, a function is a quadratic if the highest exponent is that squared term, okay? So if I have like x to the third, it's not a quadratic. If I have x to the fourth, not a quadratic, okay? So it has to have that x to the squared. X to the squared, x squared. And then A, B, and C can all be numbers, right? Any real number. The only stipulation is that A cannot be 0. Because if A is 0, 0 times x squared gets rid of that, and then I'm left with a linear function, right? Instead of a quadratic. So as long as A is not 0, we're looking at a quadratic function here. So let's review. We went over most of this last unit, but let's go ahead and review as well, just graphing quadratics and how we can do that, okay? So here we have a quadratic function in the form of a times x minus h squared plus k. They're calling this standard form. Sometimes I think in Algebra 2 you might have heard it be called not vertex graphing. Vertex form was another common way, or sometimes even maybe in your Algebra 2 class that it was called graphing form. Okay, all of the above. Okay, so it's just a special form that we have when our equation is in this form. We can easily find the vertex. We can easily find the axis of symmetry. We can find the x-intercepts, find the y-intercepts, and things like that. So when it's in this vertex form, the vertex is at the point h, k. This is h, comma, k. And just a quick reminder that you're always looking to switch the sign here, right? Because if I have like x plus 3 squared, right? And I set this equal to 0 and solve, I get x equals negative 3. Same thing if I have like x minus 5. If I set it equal to 0 and solve, I'm going to get positive 5. So just remember that we're always switching that sign there, okay? Get rid of that. Okay. Now, with my symmetry, so if I have a normal, my parent graph of a parabola, which is doing something like this. Excuse my terrible drawing. Right now, the axis of symmetry is right here along the y-axis. But if I move this graph left or right, that axis of symmetry is going to move as well, right? If I have a graph and now the parabola is doing this, now my axis of symmetry is down here. So the axis of symmetry, 1, is always going to be a vertical line. So we're always going to have the equation x equals And then it depends on how far left or right you've moved. Well, how far left or right you moved is your h value. So the axis of symmetry is always going to be the equation of the line, x equals h. Again, I don't need this, so get rid of that. Okay, and then some stuff that we talked about last unit, but just to have it all in one spot. If a is greater than 0, meaning if a is positive, the parabola opens up. And if a is negative, the parabola opens down. And then also, if the absolute value of a is greater than 1, so 3, 12, 24, right? All these numbers, right? Anything bigger than 1, remember we're grabbing the ends of that parabola and we're pulling it. We're stretching it, and the parabola is getting more narrow. So the graph is going to be vertically stretched. Okay, versus if the absolute value of a is less than 1, meaning a fraction, something less than 0, or excuse me, something less than 1 but greater than 0, so 1/2, 1/3, 3/4, 3/5, like whatever, right? That's when we're taking the ends of the parabola and we're compressing it together, so it's going to get more wide. Okay, so here the graph is vertically compressed. So just a quick rundown of that. The only other thing here is to find the x-intercepts, I'm going to set the whole equation equal to 0 and solve. Okay, so I'm going to set the whole equation equal to 0 and solve. And then to find the y-intercept, I'm going to plug in 0 in for x and solve. And we'll review that and practice that here too. So let's look at our, excuse me, let's look at our first example. Okay, our first example here says to use the vertex and intercepts to sketch the graph, give the equation of the axis of symmetry, and then use the graph to determine the domain and range. So lots of stuff going on. So let's just start with our vertex. Luckily, this equation for us is already in vertex form, so that's exciting. So my vertex is at positive 1, because remember, if I set this x minus 1 equal to 0, I get x equals 1, right? So, excuse me, so I get positive 1, comma, and then my k value is 4. So there's my vertex. My axis of symmetry, I'm going to abbreviate symmetry, is always the equation x equals h. Well, in this case, my h value is 1. So I'm going to graph the vertex at 1, 4. And then my axis of symmetry is doing that. Okay. Then it wants me to find the intercept, so let's do the y-intercept first. So the y-intercept means that I'm going to plug in 0 into the equation. So 0 for x. And we can solve. So negative 1 squared is 1, but I have this negative here, so it's negative 1 plus 4, which is 3. So my y-intercept is at the point 0, because your x is 0, comma, 3. And I can plot that here. And then because parabolas are symmetrical, I can plot it on the other side as well. All right, and then for the x-intercept, or intercepts, I guess there's two of them. So the x-intercepts, I'm going to set the equation equal to 0. And then I'm going to solve. So solving this here, I'm going to subtract 4 to the other side. That gives me negative times x minus 1 squared. Divide both sides by negative 1. Let's get rid of these negatives that we have going on. So I have 4 equals x minus 1 squared. And then I want to get rid of the square root, or sorry, the square, so we're going to square root. I'm running out of space, so let's just go up here. Don't forget that when you take the square root, when you're solving by taking the square root, you have to have that plus or minus, right? So plus, wow. We got this. We can do it. Plus or minus the square root of 4, which is 2, equals x minus 1. And then the last step is to add the x over, and it's really common for people to change this to plus or minus 3, right? Because I'm adding 1. You cannot do that, okay? So this is just going to stay plus or minus 2 plus 1. You cannot change it to plus or minus 3. When we actually calculate this out, you'll see why, okay? So I have two answers here. One where positive 2 plus 1, which is 3. And the other one is where negative 2 plus 1, which is negative 1. So you do not get 3 and negative 3. You get 3 and negative 1, okay? So here, my x-intercepts are at 3, 0, and negative 1, 0. So if I graph those, here's negative 1, 0, and then 1, 2, here's 3, 0. And that's symmetrical, so that's really good news, right? And so now I can draw it, working very hard to make that graph pretty, something like that. Then the last part says use the graph to determine the function's domain and range. Okay, so my domain, in this case, is all real numbers. So x is in the set of all real numbers. And that's just because, right, these go on forever in both directions and they just keep going out. Now my range here, my lowest value is negative infinity. And my highest value is 4. And I actually have a point at 4. That's where my vertex is. So there's my domain and range. And that's everything that it asked us to do. So that's exciting. So let's look at example B. And what I actually want you guys to do for example B, I want you guys to try this one yourself. You will get a y-intercept that doesn't fit on the graph, and that's okay. And you will get decimals for the intercepts, and that's also okay. All right, so those are your two warnings. Go ahead and hit pause. Try this one in your notes, work in pencil. If you mess up, totally fine. We'll go over it, but you should try it and make sure that you are putting in some effort here, okay? Make your brain work a little bit. Go ahead and hit pause, and I'll see you in a second. Okay, so hopefully we at least got this far where we got the vertex and the axis of symmetry. The next thing is the y-intercept, right? So I'm going to plug in 0 into my equation. I have then 4 times 4, because 2 squared is 4, minus 1, which gets me 15. And I know that that does not fit on the graph. It's like way up here. It's even more up there, right? It's like way up here. And that's okay. That's no problem. But at least I know that's where it's crossing the y-axis. Then the next thing I want to solve for are my x-intercepts. So I'm going to set the equation equal to 0 and solve. So first thing I need to do is add that 1 to the other side. Right? I'm trying to get that parentheses by itself. Now I'm going to divide by 4. I'm going to leave this as a fraction. Okay, and then when I square root and square root, people were asking me, how do I square root a fraction? Well, first of all, I know I'm going to get plus or minus, so I'm going to go ahead and do that. When we square root the top, so the square root of 1 is 1, and then we square root the bottom. The square root of 4 is 2. So nice and simple there. And then the last thing I need to do is subtract my 2. And I'm good to go. Now I just need to split these up. So positive 1/2 minus 2 gets me negative 1.5. And negative 1/2 minus 2 gets me negative 2.5. So that tells me I have x-intercepts at negative 1.5 comma 0 and negative 2.5 comma 0. which is right here and right here. And again, I know I can't cross the y-axis until way up there. So it's actually, oops. My bad. It's actually doing something like this. And it's super, 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 super narrow. So there's my graph. Now for the domain. Again, the domain is always going to, for parabolas, is in the set of all real numbers. So I can have anything I want in the domain. And then the range, my lowest value is -1, and my highest value is infinity. So hopefully that's making sense. If not, let's reach out and review some problems like this, okay? And we're going to move on to example 2. Example 2 is all about completing the square. If you do not remember how to do this, one, we're going to go over 2 problems of it. And if you still don't remember how to do it, then reach out, let me know, let your teacher know, and we'll get some extra practice and help for that, okay? But right now it wants me to describe the graph and identify the vertex by completing the square. So as the graph is written right now, or as the equation is written right now, I don't know what the vertex is because this is not in vertex form. Okay, so that's where completing the square comes in handy because it puts it into vertex form for us so I can know what the vertex is. So the first step when you complete the square is you're going to take your equation and you're going to set it equal to 0. I prefer to have the 0 on the right-hand side, and that's just a weird personal preference of mine. So I'm going to write this equation, and I'm going to set it equal to 0 on the right. Okay, so the first step in completing the square is you want to put these first 2 parentheses, or these first 2 terms in parentheses. So I have 2x squared plus 8x, and then I'm just going to have this plus 7 chilling. Plus 7 is not really going to do anything all the way down. Okay, it's just going to be off in its own little world, doing nothing. Okay. Now the goal here is for me to have this term to just be x squared. So I'm going to have to distribute out a 2. So if I take out a 2, I'm left with 2 times x squared plus 4x, close your parenthesis, plus 7 equals 0. Hi, pre-calc people. Okay, Olivia made a guest appearance for us. All right, so now what our goal is to have a perfect square here so that I can factor. So I'm going to want to add something here so that what's in the parentheses is factorable. Okay, and so the way that we find that is we use b over 2 squared, where b is your middle term, right? Remember a, b, c? But we're not using the original b, we're using the new b, which is 4. So 4 over 2 squared, which is 2 squared, which is 4. So I'm going to add 4 here. But what's happened was I have an equation that's equal, and I added 4. Well, now it's not equal anymore. And so what we actually do is we add 4, but then we also subtract 4. And I know that that seems like a little weird. Don't worry, this plus 7 is still there. But you'll see why we do that in just a second. So what we've basically done is we've had an equation that was equal. We added 4, but then we subtracted it back again. So my equation is still equal. And the reason for that is now this x squared plus 4x plus 4 is something that we can factor, and we have to think back to our factoring skills. But that factors into x plus 2 squared. Okay, and then I still have this minus 4, and then I still have the plus 7. So just a quick reminder, I'm going to erase this here in a second, but x squared plus 4x plus 4 factors into x plus 2 times x plus 2, which is the same thing as x plus 2 squared. So that's how I was able to go from x squared plus 4x plus 4 to x plus 2 squared. Okay, just so that we all are on the same page with that one. This. Okay, so now what I can do is I can distribute this 2 into that and this. The problem is I can't actually physically distribute a 2 into this x plus 2 squared because the squared is blocking that parenthesis. So what that ends up doing is just becoming 2 times x plus 2 squared. I don't actually get to multiply that in, okay? But then 2 times negative 4 is negative 8. And then that plus 7 is still just hanging out. You just rode the wave all the way down, right? And so then the last thing is that I can combine those two terms. So my function in vertex form is 2 times x plus 2 squared minus 1. And I was able to get it into vertex form or graphing form or standard form, okay? And so now I can actually describe what the graph looks like. A couple things I know what the vertex is, right? I know the vertex of this graph is negative 2, negative 1. I know that this axis of symmetry is the equation x equals negative 2. I know that this graph opens up. And the reason I know that this graph opens up, all right, so it opens up. We know that 2 is positive, so it's going to open up. And then the last thing is because this is a 2, right, it tells me that I have a vertical stretch of 2. My pen is starting to get a little jumpy here, so we'll see how we can go. A vertical stretch of 2. And it doesn't actually ask me to graph it. It doesn't ask me to find the intercepts. So it just wants me to describe the graph, and I have done that. Okay, so let's do another problem that involves completing the square. And that's going to be example 3 here. Okay, so example 3, describe the graph and identify any x-intercepts. So now I have to do both, okay? And that's okay. So I'm going to take my original function, negative x squared, plus 6x minus 8 equals 0. So that's my first step, set it equal to 0. Then I'm going to put, oh boy, I'm going to put those first two terms in parentheses. So negative x squared plus 6x goes in parentheses. And then this minus 8, I usually like to leave a little space just to remind myself I'm not doing anything with that minus 8. Now I want this term to be positive x squared, so I'm going to take out a negative 1, which leaves me negative 6x, right? And then minus 8 equals 0. Okay, now I want to find a number that goes on the end of this so that I have a perfect square. So x squared minus 6x plus something. And we don't know what that something is, so we're going to find it. So b over 2 squared. Well, my b is negative 6. Negative 6 over 2 squared is negative 3 squared, which is 9. So I'm going to add 9. Remember that if I add 9, I also have to subtract 9, right? And then that is also going to be in the parentheses. And then again, this negative 8 is just chilling. We don't do anything with that constant until the very, very end. Okay, so I have negative 1. x squared minus 6x plus 9 factors into x minus 3 squared. Hopefully we're caught up on our factoring skills. Okay, so all I did was factor there. And then I'm going to distribute this negative. So that leaves me negative 1 times x minus 3 squared. And then negative 1 times negative 9 is positive 9 minus 8 equals 0. So my function is f of x is equal to negative 1 times x minus 3 squared plus 1. So there's my function. And I don't really have a whole lot of room, but I'll try to circle it here. Perfect. Okay. So I want to describe the graph. Well, my vertex, hopefully we see, is at the point 3, comma 1. My axis of symmetry is at the equation x equals 3, because that's my h value. Oh, this opens down, and I know that it opens down because the number in front of my a, right? My a is negative, so this opens down. And there's no vertical stretch or compression because a is 1, right? So a is 1, it's just negative. But then the other thing, it wants me to find the x-intercepts. Okay, so I'm going to do the work and I'm going to find my x-intercept. So I'm going to set the equation equal to 0. So 0 equals negative 1 times x minus 3 squared plus 1. I'm going to subtract my 1 to the other side. And again, I can't do anything with the square until I get rid of this negative 1. So let's divide. So 1 equals x minus 3 squared. Now I can take the square root. Don't forget, when you take the square root, you have to do your plus or minus, right? And then the square root of 1 is 1. And x minus 3. Add 3 to both sides. Does not get me plus or minus 4. Gets me plus or minus 1 plus 3. So I have two options here. Positive 1 plus 3 is 4. And negative 1 plus 3 is 2. So my x-intercepts are at 4, 0, and 2, 0. And I've described the graph, right? And I found the x-intercepts. So that's all I needed to do. So really the big part here is just completing the square. Okay, we're gonna keep trucking along here. Question A is asking us to find two quadratic functions, one that opens up and one that opens down, whose graphs have the x-intercepts negative 7/3, 0, and 4, 0. So we have to remember that this is telling me that x is equal to negative 7/3. Well, if I want to solve this for 0, I want to get everything onto one side, I would add 7/3, add 7/3, and I get x plus 7/3 equals 0. And that's what tells me what my roots are, what my parentheses are, okay? So I have x plus 7/3. And then the other parenthesis, I have a positive 4 here. So again, if I do the same thing, x equals 4, well, if I want to solve for 0, I subtract 4. And I get x minus 4 equals 0. So then this one is going to be x minus 4. And then it's saying any graph. I can A, right? Here's my A value. It can be anything I want as long as it's positive because I want it to open up. We're going to do the up one first, okay? So I'm looking at this and I really don't like having a fraction here. It's annoying. It makes it look harder and it will make it harder. So I'm going to strategically pick my a value so that I can get rid of this fraction. And so I'm going to pick an a value of 3 because 3 on top and 3 on bottom will cancel. Okay, so I'm going to distribute. So I have 3x plus, and then the 3 over 3 cancels, and I just get 7. And then I still have x minus 4. And so now all I have to do is distribute to find the equation. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. 7 times x is 7x. And 7 times negative 4 is negative 28. And I'm going to combine my like terms. And it used y, so let's stick with y. I get y is equal to 3x squared minus 5x minus 28. And this is the one that opens upward, right? Because the 3 is positive. Now, could I have picked any number for a? Sure. I could have picked 9. I could have picked 11. I could have picked 245, right? I could pick any number I want. But I picked 3 solely for the reason to get rid of this 3. If I didn't have fractions, I would just pick 1 because it wouldn't change my problem and it would make it a lot easier. But you can pick any number you want as long as it's positive. Now let's look at the negative. So my roots are the same. I'm still going to have x plus 7/3. And I'm still going to have x minus 4. But now I just want the graph to open down. So I know that my a has to be negative. And I'm going to pick whatever value I want. So I'm still going to stick with 3 because that got rid of my fractions for me. So y equals, I'm going to distribute, and I have negative 3x minus 7 now, and then x minus 4. And now I can distribute. So I get negative 3x squared plus 12x minus 7x plus 28. Okay, and I'm going to combine my like terms. I get negative 3x squared plus 5x plus 28. Again, did I have to pick 3? No. But I did because I like that it got rid of my fractions for me. So then this is the equation that opens down. Oops. Downward. And it's just a equation, right? Every time you change a, the equation changes, but it'll still cross the x-axis at these 2 points. Hopefully we're feeling good about that. We're going to move on to example 4. We're just cruising. Example 4 says, write the equation of the parabola in standard form. So write the standard form of the equation whose vertex is 1, 2, and that passes through the point 3, negative 6. So first of all, let's remind ourselves of the standard form. So there's our standard form. And I'm given a lot of information here. A vertex tells me that it's my h and my k. And then a point tells me it's my x and my y. So the question is, can I plug in these values and solve? And the answer is yes, right? So we're just going to substitute our values in. So my y is negative 6. I don't know what my a is. My x is 3 minus my h is 1 squared plus my k is 2. And let's just simplify. So negative 6 equals 3 minus 1 is 2. 2 squared is 4. So this is 4a plus 2. Subtract my 2, I get negative 8. equals 4a. So negative 2 equals a. Now that I know what a is, I can write the equation. Y equals a is negative 2 times x minus h is 1 squared plus k is 2. So pretty quick there. All you have to do is get the value for a. And once you know a, it's pretty smooth sailing from there. Okay. Lastly, we're going to look at the minimums and maximum value. Okay, so for the parabola, here's my equation, right? The vertex, we know, is at negative b over 2a. So the x-coordinate of the vertex is negative b over 2a. And then, I don't know why I'm repeating what is already written. Negative b over 2a. And then to find the y value, I'm going to take what I got here. Let's say I got 4. And I'm going to plug it into the equation. So that's all it's saying. My x-coordinate is negative b over 2a. My y-coordinate, I'm going to take that number and plug it into my equation. Okay, so when we look at this, if the vertex is a minimum, right? So if I have a parabola doing this, the vertex is the lowest point, right? So that's a minimum. So if the vertex is a minimum, the parabola opens up. If the vertex is a maximum, right, doing something like this, if the vertex is the highest point, then the parabola opens down. Okay, and so we know whether parabola opens up or down based on my a value. And so if I know that the parabola opens up, I automatically know that it has a minimum. Okay, and then the x-coordinate is where the minimum or maximum occurs on the x-axis. And then the y-coordinate is what the y value is of that point. So when we look here, we're going to do examples A and B. So looking at problem A, all I'm really curious is, first of all, is does it have a minimum or does it have a maximum? So my first question is, does it open up or does it open down? I don't really care where it is on the coordinate plane, right? In this case, because A is positive 2, it opens up. So that should tell us, right, that it has a minimum. So it has a minimum. So we've found whether it has a minimum or a maximum, but now I actually want to find the coordinates of that minimum and maximum. So I'm going to draw my open coordinates there, and we're going to do the negative b over 2a. Okay, well, b is negative 8, so negative b is positive 8 over 2 times a, which is 2. So I get 8 over 4, which is 2. So the x-coordinate of my minimum is 2. Now to find the y-coordinate, I'm just going to plug in my x-coordinate. So I'm going to plug in 2. So I'm going to find f of 2, right, which is 2 times 2 squared minus 8 times 2 minus 3. 2 squared is 4 times 2 is 8, so 8 minus 16 minus 3, which gets me negative 11. So I have a minimum, and my minimum is at 2, negative 11. So my vertex is at 2, negative 11. And that's it. Okay. Over here, because that 2 is negative, I know that my graph is opening down. So I actually have a maximum here. So I can tell right away that I have a maximum value. And I don't know what it is yet, but we can find out. There we go. Okay. So to find it, I'm going to do my negative b over 2a. This will tell me the x-coordinate. B is negative 12, so negative b is positive 12. over 2 times a is negative 2. So I have 12 over negative 4, which is negative 3. So the x-coordinate of my vertex is at negative 3. Now to find the y-coordinate, I'm going to go ahead and plug in negative 3 into my equation. So it looks like I might run out of room. Negative 3 squared minus 12 times negative 3 plus 3. Woo, sorry. Negative 3 squared is 9 times negative 2 is negative 18. Negative 12 times negative 3 is positive 36 plus 3, which gets me a value of positive 21. So not only does this have a maximum, but the maximum is located at negative 3, 21. Hopefully we feel good about that. All good. Oh, oopsies. That's not what I wanted. There we go. And the last problem that we're going to do, we're actually not going to do question C. So example 7 here is going to be our last problem. We're going to need a graphing calculator. So let's read this. It says the numbers G of grants awarded from the National Endowment for the Humanities Fund from 1999 to 2003 can be approximated by the model G of T. Okay, where T is between 9 and 13, because T is years, right? So 9 corresponds to 1999, and then 13 would be 2003. Okay, and it says using this model, determine the year in which the number of grants awarded was the greatest. So I want to find the maximum, but I only want to find the maximum between 9 and 13. I don't care about 8, 7, 6, 5, 4, right? Or 14, 15, 16, 17. I only want the maximum between 9 and 13. So we're going to have to adjust our window here. Okay, so really the question is, what is the max? What is the maximum? Okay. And there's a couple ways that we could do it. Let's do it algebraically first, and then I'll show you how to do it on your graphing calculator, okay? So if I want to find the maximum year, all I need to do is find the x-coordinate of the vertex, right? Because that'll be the highest point. So I'm going to do my negative b over 2a. Well, my b is 2201.01, so this is negative 2201.1 over 2 times, and my a is negative 99.14. Just seems kind of messy, right? Which if I enter this into my calculator, I get about 11. So what year equates to 11? It's about 2001, right? So in 2001, the number of grants was the highest. Okay, now we're gonna talk about how to do this on your calculator. So if you don't have a graphing calculator, you can use Desmos, or there's apps on your phone, or if you need one, just as a reminder, reach out to me, because I might be able to get you one, or we can at least have you borrow one from the classroom for the semester, okay? But go ahead and get your graphing calculator out. I'm going to get mine out, and then I'm going to show you how to do this on your graphing calculator. So let's pull up the graphing calculator. So here's my graphing calculator. And I want to graph this so I can find the maximum value. So I'm going to go into y equals, and I'm going to graph my equation. So negative 99.14, and then t squared, we'll just do x squared instead, right? And then plus 2201.1 x minus 10896. Okay, great. And then I'm going to hit graph. And I get that. What the heck is that? Right? That's not very helpful. Keep in mind, I'm only curious about what's happening between 9 and 13. Right? Yes, 9 and 13. So a couple things. I'm going to go zoom, and then I'm going to go up to where it says zoom fit right here to number 0. I'm going to hit enter. And now, okay, that's better, right? It showed me at least the curve a little bit. But again, this is going from negative 10 to 10. I'm not interested in negative 10 to 10. I'm only interested in 9 to 13. So let's go to our x minimum and go 9. And our x maximum we want is 13. Okay, and now I'm going to go zoom fit again. Okay, and now it shows me this graph from 9 to 13. And it's adjusted all of the scales automatically for me. Okay, so what we're going to do is we're going to go second, trace. All right, and just like we looked at this before already, we're going to go to our maximum feature. And it wants this left bound, so I'm going to go where I clearly know it's to the left. Like that is, to me, that is clearly to the left of the maximum. And I'm going to hit enter. And that line comes up. And then it says right bound, so I'm going to go where I'm very, very, very confident that I'm to the right. So around there, enter. So you've just told your calculator that the maximum is going to be between these two lines. And you don't have to guess, so just hit enter through it. And there it is. So it's telling me my maximum is at 11.1000. So about 11 years, right? Between 11 and 12 years. And so it would be in 2001. So we were right when we did it algebraically, okay? But you can also do it on your calculator. Or we can use, and it's number 4, maximum. So whenever it's like a function that you're using on your calculator, I like to write it how it's written on your calculator. We would use the maximum function, which is under the calc menu, right? So second trace gets you to that calc. And I'll show you that again too. So right here, up here where it says calc, C-A-L-C, that's what you're getting to when you go second trace. So you'd use the maximum function under the calc menu. So we're not going to do part C. So this is it for unit 2 or lesson 2.1. A little bit shorter of a lesson, so that's exciting. And next time we'll just talk about end behavior and all sorts of fun things of other polynomial functions other than just x squared. If you have any questions, reach out. If you need anything, reach out. Otherwise, I'll see you soon.